elevated. Now it's my time to shine, yeah, let's go. Graduated, elevated. Now it's my time to shine, yeah, let's go. Major moves, power moves. Take it to the top one time non-stop. Gotta go, gotta flow. Take it to the...
Welcome to Ph.D. Hatso Kanku Lubale. It's been forever, but not that ever, since 2021. Thank you so much for agreeing to come back on Ph.D. Hard Talk. I know you've submitted. Could you please introduce yourself, your research, university, and we can crack on?
Yeah, my name, as you say, my name is Kanku Lubale. I was a PhD candidate. I've submitted. From University of KwaZulu, Natal, where I was doing my study in from the discipline of chemical engineering. And my thesis was entitled Study of the Structure of Nanomaterial by Investigating the Property of Nanoparticle. So we have tried to cover all the aspects of my research and submit it. Yeah. So excited.
Excellent. And congratulations on hitting another milestone. So the first question is, in terms of nanoparticles and nanomaterials, could you explain what that is for the audience at home? Because some people might not come from your discipline, and then we can get into the questions.
Okay. So important note, we need to understand that nanoparticle is just a material that I was using during my project. My project was really focused on fluidisation. I will try to explain what fluidisation is. Fluidisation is that chemical principle that allows a solid particle to be suspended in a column by the means of a gas or liquid. So fluidisation of a particle can play an essential role in a process such as the pharmaceutical, food, petroleum industry. So you need to understand that fluidisation of a small particle, like nanoparticle, is extremely intriguing due to its potential in the area of mixing, power handling, large gas solid contact area, and IEs and mass transfer rates. So was to investigate the structure modification of aluminum oxide nanoparticle during a rheological test of nanofluid and fluidisation of nanoparticle. So nanoparticle are those particles with a small size of below 100 nanometer. So if we we're talking about any solid particle with a size of, let's say, 50 nanometer, 60 nanometer or 2 nanometer, those are nanoparticles. All right, so anything below 100 nanometer are called nanoparticle. There are different nanomaterial, as you can say. There's nanoparticle, there are nanotubes, nanodots. There are different nanomaterial. Now, nanoparticle are amount of nanomaterial that can be synthesized. So in our research, we were dealing with a nanoparticle. In this case, was aluminum oxide nanoparticle with a size of 13 nanometer. Yeah.
Brilliant. Thank you very much for that explanation. So why should a proper investigation of structural construction of nanoparticles be conducted, in your opinion?
Yes, I think so. It's very important. Remember, this nanoparticle can be synthesized. All right. There's different methods to obtain nanoparticle, but in our case, we were dealing with the commercial nanoparticle. Those were been synthesized by any industry, and we tried to investigate the application. Now, there is that gaps that exist between synthesized nanoparticle and application. Remember, if you have nanoparticles that have been synthesized and you have to use them in different application, let's say fluidisation, in my case, you'll see that their structure will be changing. So their behavior will be due to the structure change of those small particles. Now, analyzing or investigating on the structure modification of those small particles are very crucial, because those complex phenomena that can occur in any application are due to that modification of the structure of nanoparticle. Yeah.
Thank you very much for the explanation. And how did you identify your research gap? Because I believe this is not new. How did you get to that point where you were confident that I've identified my research gap?
Yes, of course. It's a good question. Remember, thing that we have to conduct it in the lab, if it's a novel idea, novelty, you need to remember that you need to reference it. All right, so you need to people have been working in a similar research and see where they stopped and try to come up with the new ideas. I did some investigation on the rheological property of nanofluid. Nanofluid have simulated smart fluid dispersing those nanoparticles in a base fluid, which was distilled water. Okay, and people have done that work. All right, they've done that work and they have obtained the behavior of nanofluid as temperature was changing. Okay. And it's a lot of work, when you have a nanofluid and you need to measure temperature at different concentration. So in our case, we came with an idea of predicting a behavior of that nanofluid at different temperature with a correlated model. So we developed a mathematical model that can assist to obtain what other people have published instead of going to the lab and measure, and it will take you the whole day or a week. So with a mathematical model, straightforward, that can take you even minutes or hours to have the same behavior that people have obtained. So those are different gaps that we have obtained during our experiment. And other things was during our fluidization. Of course, people have literature has stated that fluidization of those small nanoparticles can only be possible if there is a formation of agglomerates. But it still needs information. We need more information to understand the growth and dissociation, because if those nanoparticles are fluidized within a growth of those nanoparticles forming agglomerate, and there is a dissociation at the same time. So we had to come up with as well the new ideas to find a model that can give us a better understanding, in order to obtain a proper or an optimum, a variable that we can use in fluidization to really control the behavior of those nanoparticles in fluidization. Yeah.
Thank you very much for explaining in great detail in terms of the different strategies that could be employed possibly to identify the gap. Thank you. Yeah. And how does your research help the economy?
Can you elaborate your question?
In the near future, let's say with your findings, because you've reached a conclusion, you know what your findings are, how does that benefit the community in terms of economically? Do we have new jobs? Are we going to have an amazing breakthrough that will help, let's say, the water sanitation in South Africa, for example? How does it benefit the country? Because the community, it can be people, it can be the country. So how does it benefit the economy?
Okay, I'll recap a bit of what we have discussed in our previous interview, where I have explained you how South Africa had an issue of water sanitation. Okay, remember, I have been dealing with nanoparticle, all right, and nanoparticle, in my case, the process that I used to investigate their behavior was fluidization, as I say, fluidization. Mm-hmm. But still, those nanoparticles can be used in wastewater treatment. Okay, mm-hmm. As I say, they can be used as well in biorefinery. They can use in many applications. And I will take a very simple example of a fluidisation, because fluidisation is the principal process that I've used on my research. And fluidisation is can be found in a, and if I state this unit, it's called fluidized bed catalytic cracking. It's a huge unit where hydrocarbon been cracked to have, you know, a carbon with the low density. Mm-hmm. They use fluidization. Now, in that unit, they use catalyst in form of powder. In most of the case, those powder are in size of a micrometer. Okay, and now they have been using nanoparticle. Nanoparticle is a new in research. It's a new in industry, and they're quite very expensive. Now today, if we try to use nanoparticle as a catalyst, nanocatalyst, for example, the industry will really benefit a lot. Like, for example, in the production of a petroleum, we're going to have more production because we use less, we use a smallest catalyst possible. Remember, when we use a small catalyst, we have a high surface area and we have high production of hydrocarbon. That is in fluidization. And if I can take as well an example of about refinery, because I did some research and esterification of biodiesel, where I've used a catalyst in form of a powder. Now, if we use a powder in form of nanoparticle, nanocatalyst, of course, we're going to have a high productivity, you know, of biodiesel. And in wastewater treatment as well. Today, we treat water with different disinfectant, you know, that can be in type of a gas, they can be in type of a liquid, they can be as well in type of a powder. And if they're in form of a powder, and we use nanoparticle, it really benefits. That would really benefit the community. As I say, if you look as well in paper that have been published with nanoparticle as a main subject of the topics, you'll see that it has a high impact. So I think the community should benefit a lot in terms of having research being taken into the lab and have information, and those information can be to the industry and obtain good results. Yeah.
Thank you very much. And I think, you know, if you were to think outside the box and we took countries like Malaysia and Thailand, they have a lot of streams and like rivers, etc. So they have a lot of water. And I'd like to think, you know, well, I'll ask you the question. Do you think the model, in terms of the information you've just shared, do you think it could be transferred in theory to such countries? And do you think it would benefit the farmers, you know, people in villages up in the mountains, because they struggle, you know, to go and fetch their water and walk up a mountain? You know, what's your vision with this? Because this is your baby, essentially. Well, you know, it's teamwork.
Yes. Yes.
So, you know, what are your thoughts?
Yes. It's really going to benefit to the people, to the community, of course, as you say. And remember, nanoparticle is still an area of solid particle that really still costly. You know, as I say previously, they are quite very expensive, very expensive. With time, as we're going along with researchers, and if we try to optimize and we have efficient or effective equipment, we can design, or we can synthesize, or we can obtain more nanoparticle possible to try to scale up in a big scale. It's still possible if we go to Malaysia, for example, and we need to treat their waters, and we have to use our model, and it's still doable. It still will be doable, you know. And remember, nanoparticle can be still used in agriculture. They can be still used in agriculture. And if you look around and you see that in any process where they use powder, and be a bit curious to know what will be the size of those powder. Even flour, sunflower that we're using for bread, even for males, you know. And if we look now in terms of the size of it, you know, and put them in size as nano size, nanoparticle, and all will benefit a lot, you know. But the whole issue that we need to face is to be able to have effective equipment to be able to synthesize nanoparticle in a big quantity, so that the large community can benefit with it, you know. And it asks a lot of funding. It will ask a lot of funding, and of course, with time, as I say, with time, we should be able to overcome that. Yeah.
I think that the point that you've made about funding is essential, because I would like to think governments, let's say in South Africa, the government, or you said municipality, that's the word you used last time, would be keen on such a project, and they would pitch that when they're having their conversations behind closed doors to say this will really benefit the farmers, the region, and will be booming, you know, in terms of the economic, you know, benefits. You know, why do you think that there isn't any backing at the moment? I know this is outside your thesis, but why do you feel like, you know, people are a bit slow to react?
Yeah, they will still be going slow to react, because you see, yes, as I say, the government cannot put themselves to any project that they don't really see what will be the output and the benefit from them as well. They need to get something as well from the project that you propose to them. See, if you look in the pharmaceutical industry, like in the drug industry, it's a small quantity. Nanoparticles have been used in pharmaceutical industry, you know, and that the reason is because it is still in the small quantity. Now, if we think about a large quantity, the government have to think about equipment, you know. And if we have to synthesize, for example, let's say 1 ton of nanoparticle per day, you'll require a really big machine, a big equipment to be able to synthesize them, you know. And people have to specialize, you know. For now, it's still in academic area site, you know, where a student can synthesize in a small quantity. And even though when you want to purchase nanoparticle, you purchase them from those research company that they can only sell to people who are in the area of research, not anyone. No one can just come, wake up in the morning, I want to buy nanoparticle. They need to know you're buying from where and is for what purpose. You know, there is a lot of protocol procedures to get those nanoparticles. But as I say, with the time coming, if the government puts more money into it and see the benefits, and if people like us, we've been working in nanoparticle and say, okay, we are convinced the government that this process will be benefit in this area for this community. Let, for example, build this kind of equipment or purchase them from overseas and be able to produce 10 tons per day and try to treat water or send them in agriculture and so on. Then we can proceed. We can put a step into it and see how it can work. But for now, the government, even though you come with your ideas and they see that it's a lot of money, it's a big money, and then we need to build this and what is the side effect of this? So it's become a bit complex, but it's still doable. With time, as I say, is a time coming. The government should be able to discover the importance of nanoparticle and put some funding into it and expand, you know, yeah. But in a private sector, I can say if anybody or a company is willingly to work in nanoparticle, let's say, for example, Sasol, and found that nanoparticle is benefits, and they want to change their nanocatalyst into to change their catalyst into nanomaterial, nanoparticle, and puts efforts and puts different units that I can have and produce synthesize more nanoparticle. Yeah, then they can do that. In terms of government, that maybe with time that would be possible. Yeah.
Okay, so I've got a good idea, I think, anyway. You might think it's bad. So I know that the ANC, they're like the new Labour in the UK, and they're pushing and they're saying, you know, this is what we want these things. If you were to pitch, is it Julius Malema? He's leading them. I don't know if I'm correct, but you know, if you were to pitch to him, because it's all about change and restoration and improving the economy and providing more employment and making redundant of any courses in university that he thinks actually you won't get a job in this climate. If you were to pitch to him now, what would you say in 3 lines? It doesn't have to be perfect, but you know, if you were to say this is why we need it, what would you say to him?
Okay, remember, he will be dealing with an engineer, and I have to simplify my ideas. So I might be starting with rural areas. Let's look, people are living in the rural areas and see their life condition. You know, they have a lack of water. Water is a big issue. And we have a simple, you know, a solution, you know, to give to people a better life, you know, give them, allow them to have a drinking water that we can treat them using our techniques, our method. If you allow us to introduce to you, you know, what we can do. It's not magic. It's just science. We have this chemical that we, this material that we call nanoparticle, and we have different processes that we can do that. We can treat water, and we have the sample. If we have a sample of, let's say, 20 milliliters, or let's say 20 liters, and we treat it in front of his eyes and try to scale up, you know. But the only issue by scaling up is the funding. So you're happy of 20 liters that I treat in front of you. That's perfect. Now let's give to this community a better water. They're consuming, for example, let's say 500 liters per day, and we will need to have this material in a bulk. We need funding. So if we can have this funding and we can have this material, these people will be served by having a potable water. So how do you think about it? And if you agree, then we can proceed to do the work. And it's not only in water, it's in agriculture as well. Give them a proper material that can make grow their vegetable faster. That could be in terms of nanoparticle, and yeah, that can give them food in a short time. So that could be my ideas. You know, the target would be the rural areas. Yeah, that could be simple because it doesn't have to go and then see the complexity of the process. You just have to see the evidence of what you are bringing into you. And if you agree to be able to treat the whole community, and it's always funding, that's really going to require. Yeah.
No, I think that was an excellent pitch. And just to add on to your pitch, I think if we opt for private and public combining the resources, it would definitely be beneficial, just to add on to what you said. So the next question is, how have you accounted for the concepts of validity, I can never say the word, and reliability in your study?
Okay, validity of my result. Remember, for example, I had to do some measurements of my agglomerate, the size of nanoparticle. I had to characterize them. You know, when nanoparticles are fluidized in the fluidized bed column, they form agglomerates, and we need to know the size of those agglomerates. And people in the literature have done similar work, and they have published as well, and they have measured those sizes. It's known, okay. And on our case as well, we have taken some other methods, you know, to characterize those sizes of agglomerate, and have values. And we try to validate with what have been published into the literature and see if it falls within the range, okay. It's give a reliable, you know, approximation of what we have obtained in our experiments. And that is kind of validation. So we cannot come with something that it's not published, you know, and say this is true. It's not provable. So it should be some other people have done the work and maybe using different methodology, and you come with another methodology and find if and discover if you have an approximate value of what that they publish. People have used, for example, techniques such as SAM and TE. SAM, it's called transmission electron microscopy, to measure the size of a small, simple nanoparticle. Some have used other method to measure the size of those agglomerates. We have used a model, a mathematical model, and obtain the size, and we validate with what people have published through the literature and see how it is, you know, is it matching with what other people have published. Of course, I think our results are quite valid and reliable with what other people have published in the literature. Yeah.